Hey guys, welcome back to my channel. So today we are going to discuss another problem. But before going forward, if you have not liked the video, please like it, subscribe to my channel and hit the bell icon so that you get notified whenever I post a new video. So let's get started. Problem is edit distance. So given two strings, word1 and word2, return the minimum number of operations required to convert word1 to word2. You have the following three operations permitted on a word. Insert a character, delete a character, replace a character. So what we are given two strings. We have to convert this first word into second word. Okay, this is the problem. So let's see the approach, how we can approach it. But before going to approach, let's discuss the problem statement first. Let's understand the problem. If you have understood the problem, you can skip to the approach part. So let's do the problem discussion. So we are given two strings. First string is horse and second string is Ross, and this is not friends wala Ross. So yeah, just a joke. Okay, so what we can do is we have three operations: insert, delete, sorry, insert, delete and replace. Okay, so these three operations we can do, and what we basically need to do is we need to convert this string into this string. All right, so let's see what we can do. So first of all, if we have h, here we have h, here we have r, right? We have here we have h, here we have r. What we can do is we can replace this h with r. So we can do either of these three operations, but right now I'm just replacing this h with r. So if I replace this h with r, it will become r and rest of the string. So in place of h it will come r and o r s e. Okay, and this is ros. So this R and this R is now matching. They are matching now. So rest of the string here we have to deal with is this one and this. So basically now this ORSE we have to convert basically to OS. This OS, the left one. So you can see that okay, this is matching, this is matching, this is matching. So it's fine, right? So these two characters are already matching. So now we will be checking this one, RSE, and here S, because this O is already matching with this one. So this thing we have to convert to IS. So it's very easy, right? What we can do, remove this R, remove this E. So we will get what? S. And here also we have S. So we have converted this one to this. So basically what we have done three operations. One operation was to replacing this H with R. Second operation was deleting this R, and third operation was deleting this E. So total of three operations we have done to convert this string to this. If you see here, here there is R, O, R, O, and this R and this E we have removed. So ROS, ROS string. So basically we have converted this horse into ROS. So I hope you understood the problem. Total of three operations are required, so output is 3. So we have to tell the minimum number of operations. You can do more than 3 operations also. You can take different cases like insert, delete and all that you can do, and you will see that 3 is the minimum number of operations which we can get to convert this word1 to word2. Alright, so now let's see the approach, how we can approach this problem. I hope you have understood the problem statement. So let's me just write the test case again. So word1 is given, which is horse, and word 2 is Ross. Okay, see, now whenever here you have three options, right? For every character you have three options. So whenever you have options, right, whenever you have options, think of using recursion. Think of using recursion. Three options are either we can insert, either we can delete, or we can replace. Okay, So let's see what will happen in each of these cases. We have seen how the output is coming 3. Now let's see how we can approach using recursion here. Okay, so let me quickly write this horse and Ross. So guys, if you see, right, let's say you have, first of all, let's say, basically let's start from the back. You can start from the front also. Let's start from the back. So here these two characters are there. E is there, S is there. Ideally we have to convert this horse into this string, right? So I have three options. Either I can insert a character at the back here. Okay, let's say I have since I want S, right? I want S. So let's say I'm inserting S here so that this S and this S matches, right? So let's say here I'm inserting. So here in this case I'm inserting. So if I'm inserting here, the rest of the string which will be passed to recursion. Recursion, what we do some work and we pass the rest of the string to recursion, right? So we do some work and rest of the whatever is left we pass to the recursion. We pass to recursion. So if I'm inserting here, I'm doing one operation. So rest of the string will be what? If S is added here, rest of the string left will be this one, right? And for this, since S and S is matching, so now rest of the string left is this one. Okay, so let's say if the original W1, this was W1 and this was W2, if W1 length was M and W2 length was N, after inserting the rest of the string length which we will pass to recursion, for W1 it will be M only because this extra character we have added here, M. And for W2, what do you think will be the rest of the length which we will pass to recursion? Since total length was N and this S character is now matching, so rest of the string which we pass to recursion will have length N minus 1. Why minus 1? Because this character is already matching. So this was case of insertion. Just hold on, you will understand everything. Now let's see the second case. So we have options here, right? We have options, that's why we are choosing recursion. Second option is we can delete also. So let's see the delete case. Let's see the delete case. So let's say we have this word horse and word 2 is Ross. Now see here, this is the last character, this is the last character. I can also delete. So when I'm saying I'm deleting, I mean I'm deleting this E character, right? I'm deleting this E character so that this character might match with this character. Okay, so I'm deleting this because, why I'm deleting? Because this E is not matching the last character here. Because I want them to match, and since E is not matching with this S, I'm deleting E from the string because it's no use to me. So if I'm deleting, what do you think will be passing to the recursion? For W1, what will be the length, and W2, what will be the length? See, if this was the total M length and this was the total N length, since one character we are deleting from word 1, the total length will now pass to recursion will be M minus 1 because we have deleted this E. And since we have just deleted, we are not sure that this and this will match. So for this, the rest of the string pass will be N only. So this was the delete case. Now let's see the third case, which is replace. Third case, which is replace. W1 and W2. Here we have horse and here we have Ross. So for replace, here it's E, here it's S. So when I say replace, it means I will be replacing this character with whatever I want. Because I want S, so I will be replacing E with S. Okay, so here in place of E, now S will be there. Now they are matching, right? They are matching. So W1, so recursion length, the length of the string which we will pass to recursion will be what? This was total M and this was total N. Since now they are matching, the total length, the rest of the string which will be passing will be this one and this one. That is M minus 1 because S, E have replaced with S, so it's matching, and W2 will be n minus 1. Why n minus 1? Because S is matching with this one. So this is basically how we'll approach this problem. We'll be taking all the scenarios, we will do recursion on the string, or for each character we will be having three options. Okay, what is the approach? For three, for all, for any character, right? Any character, any character, we have three options. Either we insert, we delete, or we replace. Okay, and whatever, in each of the cases, the recursion, rest of the string will be m minus, here it was what, m n minus 1 in case of insertion, m n minus 1, here it was m minus 1 n, and here was m minus 1 n minus 1, which will be passing to the this recursion. So I hope you understood this approach. Let's see the dry run now. It will be more clear with the dry run. So let's see the dry run. Quickly writing the test case again. Sorry, bear with me, horse. And here we have Ross. So see, now I will now we will see how we can use the above approach here. So see, I will start from the end. You can start from the beginning also. Here this is E. Here the last character is E, and here it's S. Okay, and here it's S. So first thing which I will do. First thing which I will do is I will delete this E. That is, I have three options, right? With this E character, with this E, I can do three things. Either I can insert, either I can delete, or I can replace. Here I am choosing to delete. You can, because this is recursion, right? So all these three cases will, executed. But I am just like, for the dry run purpose, I'll just delete this E. So this, because we want what? Why we are doing operations on this one? Because we need to convert this string into this one, right? That's why we are doing here. So see, if I delete the C, the rest of the string which will be passed is HORS and ROS, right? HORS, this E is deleted. Here this string is passed, and here rest of the string which will pass to recursion will be this one left. And one operation is done. That is delete operation is done. Now this is S, the last character is S, and here also it's S. So they are matching. So since they are matching, nothing we should, obviously there is no need to do anything, no operation. So rest of, we will just simply pass to the recursion the rest of the string. So that is the recursion, the string which will be passed to recursion will be HOR and RO, right? Okay, so here the last character is this one, last character is this one. Now what do you think we should do? Here it's O, here it's O, and here it's R. Here it's O, here it's R. I'll delete this R again. So what I'll do, I will delete this R again. So if I delete this R, I'm doing one more operation, deleting R. So rest of the string will be HO, and here it will be RO, right? I'm just deleting this R. So now the last character is this, last character is this. O and O are matching. So we will do nothing, and we will just pass the rest of the string to recursion, which is H, and here it's R. Now what do you think we should do? Only one character left, so we can just simply replace this H with this R. So third operation which I am doing is replacing, replace. So H will be replaced with R, and here it's also R. So these are matching. So we will do nothing, and we will just simply pass the rest of the string to recursion. So rest of the string is empty. Here also rest of the string is empty. Now when the string becomes empty, it means we have done the conversion, and these are the total operations which are required, which are three. So I hope you understood the dry run and the approach. It's very easy problem. Let's understand the code once, and also dry run the code yourself, because if you don't dry run yourself, it won't be clear. Just understand the recursion concept first. We will see why we are doing memoization here, but before that, just understand the recursion part. So this function is given minimum distance, in which we have two words, word 1 and word 2. Okay, and we are calling this helper function, in which we are passing word 1, word 2, and don't see this dp first, like just ignore this dp. We'll understand why we are using memoization concept here, but just understand recursion first. And we are passing the length, because since see we were starting from the end, right? So I'll be iterating from the last index. I will iterating from the last index. Okay, this is m is the length of the first word, n is the length of the second word. So let's see what is happening in this helper function. um See, I and j, this is a that one, the length, this will be the index value. So see, if the last index character is matching, if these two are matching, for example, here let's say this, here let's say this s was matching with s, here s was matching, right, the last in the characters. So we pass the just the rest of the string, that is m minus 1 and n minus 1 length. If this is total m and this is total n, so one character, this is s is, because they are same, so we are just removing them and passing the rest of the string to the recursion. So m minus 1, this is the length, right? I minus 1, j minus 1 we are passing. Otherwise, we have three operations. Either we can insert, we can delete, or we can replace. Okay. For example, for this R, we have three options. Either we can insert, delete, or replace. Although I have here deleted this R, but we have to do all the three operations, right? So we saw that if we have to do insertion, the rest of the string passed will be m for the first one, n minus 1 for the second. So insertion I and j minus 1. For deletion, I minus 1 j, and for replace, I minus 1 j minus 1. Okay, and whichever will give us the minimum number of operations, we will take the minimum and we will add 1, because we are doing one operation here also, right? This insertion, deletion, and replace. So 1 for that. Okay, so this was your recursive solution. Now why we are using memoization here? Because see, why we are doing memoization? Because there might be repetitive subproblems. Since we are doing recursion here, if you see other cases, if you draw the whole tree for this, right, for this problem, if you draw the whole recursive tree, right, you will understand there are repetitive subproblems, right? That is, there might be a case for which we have already calculated the result and it's again coming up. So I'm not drawing the tree here. That's your task, you have to draw it by yourself. So that's why we are using memoization here. Very easy. What we are just doing, we are taking a vector of length m n, okay, m plus 1 n plus 1, and then initializing it with minus 1. Okay, and what we are doing here is that if we have already, we'll be storing the value, the calculated results. So here, for let's say this ij, if we have already calculated the result, that is, it means it's not equal to minus 1, so we just return that value. If let's say, what is this? So this is the base case, this is the base case, this is, and these are two other base cases. So what does that mean? See, if let's say your one of the string is empty, you are given w1, you are given to w2. Let's say w1 is ros and w2 is empty. So if one of the string is empty, how many operations you will have to do to convert this string into empty string? You have to do the length of these whatever the length of this word is, because you can delete, right? In order to obviously make it to this one, you have to delete only, so as to make it empty, right? So if your j is 0, so you will be returning I, that is length of this string. And similarly, if let's say your w1 is here and w2 is here, let's say your w2 is ros and your w1 is empty, so in that case you'll have to do insertion here because this is empty. How many insertions? This, the length of this much, because you have to make w1 equal to w2. So that is, if your w1 I is equal to 0, this I is length, right? If this is 0, it means how many number of operations? J, right? J is the length of the w2. So these are two the base cases. I hope you understood the problem and the approach. If you have any doubts, let me know in the comments. If you found the video helpful, please like it, subscribe to my channel, and I'll see you in the next video. Thank you.